Good morning, class. Okay, this is a lesson on proof in plane geometry. So for this chapter, you need to use your concepts learned in your EMAF. Okay, so you have learned about congruency tests. So your test for congruency is SSS, right? SAS, right? One angle, two sides. AAS, two angle, one side, or ASA. So there's a difference between AAS and ASA. So ASA means that the side must be in between the two angles like this. Okay, so this is the side that you use, and these two are the angles that you're using. Whereas for AAS, it could be angle, okay, angle, side. Okay, please do not write. Okay, and then for similar triangles, right, you have all corresponding angles are equal, or AA similarity, okay, or all corresponding sides are proportional, or the third one, okay, you have one pair of equal corresponding angle and two pairs of proportional corresponding sides. Okay, so please make sure that you write it properly for similar triangles. Usually it is the AA similarity. Okay, however, if they give you like, some of the measurements for the sides, then you need to be alerted. Okay, so then properties of circles. So this is what you learned in EMAF, so it's important, right? So you have angle at center equals to twice angle at the circumference. So the first property, so please be alert, right? If it's from the same arc, right, you will have angle at the center equals to twice angle at the circumference. Okay, so this will also be equals to B. Okay, right? On the other hand, if you have this, okay, so if they ask you what is the size of angle C, then this will be the angle at the circumference. It's touching the circumference, right? Then it's from the same arc. Okay, this would be half of the reflex angle. Okay, right? So this will be half of the reflex angle at the center. Okay, so for angle at the center equals to twice angle at the circumference, there will be two types, so you need to be alert. Okay, then B. Right angle in the semicircle. So whenever they mention diameter, please be alert that you will have angle in the semicircle. You don't have to put right angle in a semicircle. You can just put angle in a semicircle will do. Okay. Then see, angles in the same segment of circle are equal. So angles in the same segment, this is very familiar to you. Okay, so it is like a, the butterfly or the Batman. Okay, so this will be equals to this. Okay, also, if you have a diagram like this one, the second one, okay, you have equal chords, AB, right, and BC, then the angles that they subtend will be equal. So this will be A, this will be angle A. So equal angles if the chords are equal. Okay? Right, then we go into cyclic chords. So cyclic chords are four-sided figures in a circle. All the four vertices must touch the circumference of the circle. So cyclic chord, so you will have opposite angles are supplementary. So we will use angles in opposite segment. Okay, so please make sure that you spell correctly, yeah, class? So B plus D will be equals to 180, and A plus C will be equals to 180. You will use this quite often, okay? Angles in opposite segments. Right, then E, so a straight line drawn from the center of the circle to bisect a chord is perpendicular to the chord. So you have a straight line from the center of a circle, and then it is 90 degrees to the chord, then it will cut the chord into two. Okay, so perpendicular bisector of a chord passes through the center of a circle. Okay, so chords which are equal distance from the center are equal. So for example, you have a center of circle here, and then you have two chords. How do you know that they are of the same length? Okay, they will be of the same length if, let's say, the distance from the center of the circle to the chord are equal. Okay, so if these two distances are equal, then the two chords will be equal. Okay, so equal chords are equal distance from the center. Okay, so this two property deals with chords, right? Then you also have properties that deal with tangents. So a tangent to a circle is perpendicular to the radius. So tangent perpendicular to the radius. Okay, so this you use it for A math circles, right? When you have a tangent and a circle. Okay, very often used. And then you have another property on tangents as well. Tangents drawn to a circle from an external point are equal. Okay, so you have the ice cream cone question. So the line joining the external point to the center bisect the angle between the tangents. So basically your triangle APO is congruent to triangle BPO. Okay, tangents from exterior point. So this is radius, it's 90 degrees, tangent perpendicular to radius, this is common side, this is tangent from exterior point. There are many ways in which you can prove that these two triangles are congruent. Okay, right. So these are the properties that you need to use for a proof in Geom, right, in A math. And of course, two theorems, okay, which is specific only for A math students, so you don't need to use this much in your E math. Okay. All right. So midpoint theorem for triangle. So in triangle ABC, if D and E are stated as midpoints of the side AB and AC respectively, then DE will be parallel to BC and DE will be half the length of BC. So this is essentially midpoint theorem. Okay, so by the converse of the midpoint theorem, if BC is parallel to DE and BC is twice the length of DE, then you can conclude that D and E are midpoints of AB and AC. So that's the converse. Okay, so for midpoint theorem, it starts off with telling you that D and E are midpoint. Then you can conclude parallel lines and the length of the two sides. Okay, right. Tangent chord theorem or alternate segment theorem, so all of you should know, and you need to be very clear about this. So as long as you have a circle and you have a tangent, so when you see the word tangent, please be alerted. Okay, and then you have a triangle inside the circle, right? There can be many triangles, so you need to be careful. Okay, so you have this angle, let's say this is angle theta, then this angle will be equal to theta as well. Reason, angle in alternate segment. Okay, or alternate segment theorem. Okay, also if you have this angle here, okay, alpha, then this will be equals to alpha as well. Okay, so then this, maybe you call this as beta, right? So theta plus beta plus alpha gives you 180 degrees. Okay, so got it? So you can also have tangent from the other side. For example, I can have a tangent here. So if I have a tangent here, then this angle here will be equal to this angle, beta. Right? Can you see? Okay, because this is your chord, this is your tangent. Right? So the angle that is opposite the chord will be equals to beta, so which is this one. Yeah? So just now you have this tangent, right? Alright? And then you have this as your alpha, right? And this is the chord, isn't it? This is a chord, right? So the angle opposite the chord will be equals to alpha, which is this. Okay, class? So don't get it wrong, yeah? Right, so we will go to some examples. So for proof in Geom, sums, usually they'll ask you to prove congruent triangle or similar triangles, or to prove, the ratio of the sides, okay, or to prove that whether, a side bisect an angle. Okay, so these are some variations. So you look at your TYS, so look at what questions have been asked thus far. Okay, so one example is here. We'll go through a few. Now, a circle passes through 6 points, right? A, F, H, B, C, and G, as shown in the diagram. D and B are 2 points on AE, right? And AD is equals to DB is equals to BE is equals to DF, so a lot of equal sides. And GCE and FDC are straight lines. Okay, so prove that triangle ADF is congruent to CDB. Okay, so one. Okay, so angle FAD is equals to angle BCD. So FAD and BCD. So when they say the triangle ADF is congruent to triangle CDB, the question you should ask yourself is, why is angle A equal to angle C? Right? Why is angle A equals to angle C? So straight away you mark this two angle out, then you notice, oh, because it's angle in the same segment. Okay, so you put down the reason, angles in the same segment. Okay, then you go on to see whether there's any equal side. Yes, so it's given the FD, right, is equals to BD. Okay, this is given. Okay, FD and BD, this one. Okay, they're equal. And then the last one will be this angle, angle D. So angle ADF is equals to angle CDB. Okay, vertically opposite angles. Right? So therefore, triangle ADF is congruent to triangle CDB. Okay, so reason would be angle, angle, side. Okay, then part 2. Prove that triangle GEA is similar to BEC. GEA is here. Wow, that's a big one, huh? This one. Is similar to triangle BEC. BEC is a smaller one. This one. The green one. Okay, straight away you can see something. Common angle. Okay, so your common angle is E. Right? Your common angle is E. Yeah. So angle GEA is equals to angle BEC. Okay, reason, common angle. Okay, and then is there any other properties that you can find? So you can ask yourself why angle G is equals to angle B. Okay, so what you can do is that you can let this angle be theta. Okay, so let angle ABC be theta. Okay, so angle EGA is equals to 180 minus theta, right? Angles in opposite segment. You have a cyclic chord, right? ABCG. Then angle EGA, yeah? So it's EBC. It's also equals to 180 minus theta, but the reason is different. This will be adjacent angles on a straight line. Okay, so this two means that angle EGA is equals to angle EBC. So you have two angles, so therefore triangle GEA is similar to triangle BEC, right? AA similarity. Okay, and the last one would be to find the ratio. Okay, the last one, I'm just going to put it here, but 3, right? Okay, the ratio of GA to AF. Okay, GA to AF, huh? Okay, so you notice that GA is this length, right? Okay, and AF. And you notice that AF is the same as BC. So this is equals to GA is to BC. Okay, BC is here. Okay, why did I use this? You see your GA is here, right, class? And your BC, corresponding sides of similar triangles. Okay, so this will be equal to AE, which is the big base. Can you see the big base here? Is to BE, the small base here. Okay, the small base here, because the smaller triangle, similar triangle, BE. Okay, so this ratio you will know, right? Because you have this is equals to this is equals to this. So AE is actually 3 times and BE is 1 time. So this is the answer. Okay, so initially you may not be able to tell that quickly because they use GA and AF. So you need to actually use the right length and to compare the length. Okay, right class? Okay class, okay, the use of midpoint theorem. Okay, the diagram shows a quadrilateral HIJK, right, with L, M, N, and O being midpoints of HK, HI, IJ, and JK respectively. Okay, so this is a big clue, isn't it? Midpoints, right? So show that LM, okay, LM is there. MN, O, and this is a parallelogram. So in order for you to prove that it is a parallelogram, you need to prove that the opposite sides are equal and parallel. Okay, the opposite sides are equal and parallel. That's all. Okay, so in this case, using midpoint theorem, right, MN is equals to half HJ. Right, MN is equals to half of HJ. Isn't it? This HJ, yeah? Okay, why is that so? Because M and N are midpoints of HI and IJ. So they already told you. Okay? So therefore, MN will be parallel to HJ and MN will be half of HJ. Okay, and MN is parallel to HJ. And LO will be equals to half of HJ and LO is parallel to HJ. Right, easily done. So therefore, it means that MN is equals to LO and MN is parallel to LO. Okay, so since LMNO has a pair of opposite sides that are parallel and equal in length, therefore LMNO is a parallelogram shown. Okay, so to show a quadrilateral is a parallelogram, you just need to show that the two opposite sides are parallel and of equal length. You don't have to show 4 sides. You just need to show 2 opposite sides are parallel and equal in length, because the other 2 will naturally fall in place. Okay, right. Okay, the diagram shows a triangle ABC inscribed in a circle. So inscribed meaning that the 3 vertices will touch the circumference of the circle, and XY is a tangent to the circle at A. Okay, once you see the word tangent, so be alerted. Yeah, so okay, so AC bisect angle BAY. BAY, AC bisect angle BAY. So you have this and you have this. Okay, prove that triangle ABC is isosceles. Okay, prove that triangle ABC is isosceles. So in this case, there's no way that you're going to prove the sides are equal, yeah, class. So you need to prove that the angles are equal. Okay, so we start off with letting angle CAY equals to theta. Okay, so once you have a tangent and you have a chord here, so you know that this will be equals to theta. Alright, therefore angle ABY is equals to angle CAY is equals to theta. Why? Tangent chord theorem. Or some of you are more familiar, alternate segment theorem. Okay, you can also put tangent chord theorem. Okay, so that you know that angle B is theta, and you also know that angle CAB is equals to theta. Why? Because they say that AC bisect angle BAY. Okay, so your CAB is equals to your CAY. Okay, so this is also equals to theta. So therefore, since angle, right, ABC or ABC is equals to angle CAB is equals to theta, right? So instead of putting Y, I think I will just put, let me just clean this off, instead of putting it as Y, I put AB. Let's put AB, right? ABC, okay, is equals to CAY. Yeah. Okay, so angle ABC is equals to angle CAB, right? So it's equals to theta, so therefore triangle ABC is isosceles, right? So base angles of isosceles triangle. Okay, done. Okay, part 2. Triangle AYC is similar to triangle BYA. AYC is similar to BYA. BYA. Right? Triangle AYC is similar. So AYC is this one. And BYA is this one. Okay? So AYC and BYA. Right? So how do you prove that they're similar? So you know that that is a common angle, Y. Okay, so you write angle AYC is equals to angle BYA. Common angle. Usually, yeah, class, when you see the common point there is usually common angle. Right, so B alerted. So you have one angle. Okay, the other angle, then you ask yourself, why is angle A equals to angle B? So angle A of the purple one is theta, angle B of the green one is also theta. So therefore angle A, right? So it's C, so it's angle YAC. Okay, YAC, YAC is equals to angle YBC, right? YBC. Okay, is equals to theta. This one is from part 1. So therefore, triangle YAYC is similar to triangle BYA. AA similarity. Okay, done. Okay. Okay, we just try some O-level question, the more recent ones. Okay, 2020, I think this is quite familiar to a lot of you. Okay, but we just go through again. So it's a 5-mark question. Okay, diagram shows a circle passing through the points A, B, and C. A, B, and C, right? The straight line SAT is a tangent to the circle. So once you see tangent, okay, be alerted. Okay, so you know that this angle, okay, straight away, right? I will just put this angle, theta. Okay, so this is theta, and then the other angle that is theta will be your angle B here. Okay, tangent chord theorem. Okay, so I just put it down that way. Okay, now, so the points D and E lie on AB, right? And AC respectively, and such that BCED is a cyclic chord. Okay, BCED is a cyclic chord. Prove that DE is parallel to ST. Okay, so when they say cyclic chord, again, the properties of cyclic chord you need to be alerted. So you'll be wondering, why is it that the quadrilateral is hanging in the circle? Because the cyclic chord actually is a cyclic chord of another circle. Yeah. So they won't tell you. Okay, so prove that DE is parallel to ST. So essentially, you need to prove that angle DEA is also equals to theta. Okay, which is not difficult because you know that angle, right? DEC is 180 minus theta. Okay, so first thing, let angle CAT equals to theta. So therefore, angle CBD or CBD or CBA is equals to angle CAT. Reason being alternate segment theorem. Okay, so therefore angle DEC is equals to 180 degrees minus theta. Why? Angles in opposite segments. Okay, right? Because they say that BCED is a cyclic chord. Okay, so once you know that this is 180 minus theta, so you will know that angle DEC is equals to 180 degrees minus 180 degrees minus theta. So it's equals to theta. Reason, adjacent angles on a straight line. Okay, so therefore, since angle DEC is equals to angle CAT is equals to theta, right? By the converse of the circle property alternate angles. Okay, by the converse of the circle property of alternate angles, we say that DE is parallel to ST, shown. Okay, so 5 marks, class, 5 marks. So essentially, how would they mark it? So as long as they see this reason given, okay, this is 1 mark because they want to see this, right? It's in the syllabus, so they will test you. Okay, and then they want to see that you make use of the property of the cyclic chord. Okay, angles in alternate segment. So 1 mark, 1 mark. So another mark here. Okay, the reasons given. Okay, and then here 1 mark, and then finally the statement. Okay, so you need to say that it is by the converse of the circle property of alternate angles. Okay, right? Okay, class, so this question is in your 2021, right? 2021. So in the diagram, A, B, and C lie on a circle. So the tangents to the circle at A and C meet at T, and BA is parallel to CT. Prove that triangle ABC is isosceles. Okay, so in this case, so again, they give you tangents, right? So once they give you tangents, please be alerted. Okay, and then they give you parallel lines, which means that you need to use probably alternate angles. Okay, so you're supposed to prove ABC is isosceles. From the diagram, probably, okay, you need to prove that angle B is equal to angle A lah. Yeah, class? Okay, so that's my initial thoughts. So what I can do is that, okay, so if I have tangent here, let's extend it a little bit. So what I can do is that I can let this be theta. Okay, so tangent chord theorem, if this is theta, then this is theta. Yeah, correct. Alternate segment theorem or tangent chord theorem. And then this is also theta. Oh, so got it already, alternate angles. Okay, so quite easy, Alright, so we're going to write the proof. Okay. So actually, class, your proof in JOM is not that difficult as long as you know your properties well. Okay. Please do not leave it blank in the exam. Okay. You definitely can write something. Even if you think that it is not correct, you're not sure, you leave it there so that they can give you marks. Okay. Alright, so first of all, I let this be theta. So let angle TCA equals to theta, right? So therefore, an angle CAB is also equals to theta because alternate angles. Why? Because it told you that BA is parallel to CT. And then angle ABC is also equals to theta. So it's tangent chord theorem. Right? So therefore, since angle ABC is equals to angle CBA is equals to theta, triangle ABC is isosceles. Right? Isosceles. Isosceles. Okay? Right? So base angles of an isosceles triangle are equal. Okay, so shown. And how would they mark it? Okay, so first of all, you need to say that angle ABC CBA is equals to theta. Okay, reason alternate angles, and then you code tangent chord theorem correctly, right? And then since this is equals to this, right? Therefore, it is isosceles triangles. Okay, 4 marks. Quite easily done. Okay, for your part B, there's a part B, class. It's not printed. So part B, you're supposed to prove that angle BCA is equals to angle CTA. Okay, so angle BCA is here. Okay, you need to prove that this angle, right, is equal to CTA. Okay, so please have highlighters on your in your pencil case. You will probably need it to mark on the diagram. So that is your work. Okay, right, now prove that angle BCA is equal to CTA. Okay, so all right, so from part A, right, so angle CBA is equal to theta, so therefore angle CAT is also equals to theta, right? Tangent chord theorem. Right, so this is also equals to theta. So therefore, So angle BCA is equals to 180 minus 2 theta, and angle CTA is also 180 minus 2 theta. So therefore, angle BCA is equals to angle CTA, shown. Okay, quite easily done. Yeah? Okay, class, so this is a question from 2022, which was last year. Okay, so 6 marks, huh? Okay, the diagram shows a circle center O with diameter PQ, right? PQ. The line PT is a tangent to the circle at P. So they always mention diameter. So you know that you're going to have 90 degrees here. And then they mention tangent, right? So you know that you're going to have tangent chord theorem. So straight away, if this is x, right? This is x. Okay, so you know that this is x. Okay, so again, this is the chord. So the angle that's opposite the chord will be equal to the angle that the chord makes with the tangent. Okay, so then we look at further information. The point R lies on the circle and the tangent of the circle at R meets PT at S. QRT is a straight line and angle RPS is equal to X. Okay, so you're supposed to prove in either order. Okay, that angle RST is this, is 2x. Okay, and triangle RST is isosceles. Okay, so I'll start off with angle PQR is equals to angle RPS is equals to X, tangent chord theorem. It's 3 marks, class, so not that long. So, and then therefore angle POR is equals to 2x. Why? Angle at center equals to twice angle at circumference. Right? So you have this one. And then from the same arc PR, you have angle at the circumference. So this is 2x. Okay, and then angle OPS is equals to angle ORS is equals to 90 degrees. Why? Tangent perpendicular to radius. Right? So therefore, angle PSR, it will be equal to 180 minus 90 minus 90 minus 2x, which is equals to 180 degrees minus 2x. This one is what? Sum of angle in a chord. Okay, so since this is 180 degrees minus 2x, so therefore angle RST will be equals to 2x. Right? Adjacent angles on a straight line. Shown. Okay, so easily done. Right? So part 2, prove that triangle RST is isosceles. So which means that I need to prove that the angle R is equal to angle T. Okay, so this is not that difficult. Okay. Okay, class part 2, I need to prove that triangle RST. Okay, RST, this angle, this triangle is isosceles. So essentially, I need to prove that these two angles are equal. Okay, so I know for a fact that this is X, right? Because these two are tangent, and therefore this is actually 90 minus X, and this also will be 90 minus X. Okay, so that's how I'm going to prove. Okay, let's go about doing it. Okay, so I will say that angle PRS is equals to X, right? Because tangent from exterior point. Okay, right? So please spell it out, tangents class. Okay, I'm just writing short form because I don't have space. So this is equals to X, and then So angle SRT will be equals to 90 degrees minus X, right? Because angle PRT is equals to 90 degrees, right? Because the other one, QRP is equals to 90, angle in semicircle. Okay, since angle QRP is equals to 90 degrees. Okay, angle in semicircle. Because you haven't mentioned this at all in your proof previously, so you better put it in. Okay, so then, so I know that this is 90 degrees minus X. Okay, then in triangle, PRT, right, the big triangle PRT here, the big triangle. Okay, angle RTP will be equals to 180 minus your X here and minus your 90 degrees. So it'll be 90 degrees minus X, right? Since angle SRT is equals to angle RTP or RTS is equals to 90 degrees minus X, triangle RST is isosceles, right? So base angles, comma, isosceles, triangle. So shown, right? So it's not difficult at all. It's just that you need to write your proof systematically. Okay, so this is a little bit squeezy because I don't have space. So in the exam, you will have space because each part of the question they'll give you almost like one whole page to do. Yeah, class? So proof in geom is very doable. Basically, you just need to be more familiar. You just need to visualize it a little bit more and then think of your properties. Okay, so keywords, you know, whenever they have diameter, think of 90 degrees angle in a semicircle. Whenever they have a tangent, think of your tangent chord theorem. Okay? Okay, class, this is from 2018. Okay, so in the diagram, a line from a point A intersects a circle at the points B. Okay, and C. The line AP is a tangent to the circle. So again, tangent to the circle. So be alert at the point P. So immediately you can see a few things. So this is, you can use your pencil, class. So this one is your theta. If this is a theta, then you have a triangle, right? Draw up to the end, the three vertices must touch the circle. So if this is theta, then immediately you know this is theta, tangent chord theorem. Okay, then the point Q lies on AC such that AP is equals to AQ. So isosceles. Prove that PQ bisects angle BPC. Okay, BPC. So you're supposed to prove that this angle is equal to this angle. Okay, all right, so we're going to start now. So I can have tangent chord theorem. All right, so I can let angle APB equals to theta and angle BPQ equals to alpha. So I let this be alpha. Okay, so immediately I will know that angle AQP is also equals to theta plus alpha. Since AP is equals to AQ, right? Triangle APQ is isosceles, or base angles of an isosceles triangle. Okay, so I know that angle, theta plus alpha. All right, and because angle APB is theta, angle BPC, angle BCP, right? BCP is equals to theta, right? Tangent chord theorem. Okay, so you need to write that it is equals to angle APB. Which angle? Okay, so I know that this is equals to theta. All right, so in triangle CPQ, right, this triangle, actually you already found your answer. This one is your triangle, right? So angle QPC plus angle okay, hang on class. So in triangle CPQ, right, the green triangle CPQ, this one, okay, theta plus angle QPC is equals to exterior angle BQB, BQP. So theta plus angle QPC is equals to theta plus alpha. So therefore QPC is equals to alpha. QPC is equals to alpha. So since angle QPC is equals to, where is the other alpha is here, right? Right? Is equals to angle BPQ is equals to alpha, right? PQ bisect angle BPC shown. Okay, so this is in 2018. Easily done. Okay class, this is in 2019. Now in 2020 there wasn't any proof in Geom because of COVID, so that was the last topic. So let's see what is in 2019. Okay, so in the diagram, PQ is the diameter of a circle. So once you see the word diameter, immediately you look for 90 degrees. Okay, and then triangle PQR is isosceles. Okay, so this is isosceles with PQ equals to PR. So this the angle should be equal. So it can be theta, can be theta. Okay, the line QR intersect the circle at T. So the tangent to the circle at T meets PR at S. All right. Show that angle TSR is equal to 90 degrees. Okay, so they want you to prove that this is 90 degrees. Okay, so what happened is that you have a tangent. So when you see the word tangent, be alert. Okay, so this is a tangent. So immediately you have, this is the chord, you have this chord. Okay, right, you have this chord, right? So therefore this angle here, okay, can let it be alpha, right? This angle will be equal to this angle. Yeah, okay, right? And then your alpha plus theta will be equal to 90 degrees straight away, right? You'll be able to prove it. Okay, so that is how you're going to go about your proof, right? Okay, so you're going to start writing it out. I'm going to clean all this out. Okay, so first of all, right, you let this be theta. So let angle PQT equals to theta. So therefore angle TRS or TRP, which is equals to angle TRS, is also equals to theta. Base angles isosceles triangle. Okay, 1 mark. Then you let this be alpha. Okay, so angle, name it U. QTU is equals to alpha. So therefore this is equals to angle QPT. Right? Tangent chord theorem. Okay, and then this is 90, right? and angle QTP is equals to 90 degrees, angle in a semicircle. So which means that theta plus alpha is equals to 180 minus 90, which is 90 degrees. Angle sum of a triangle. Okay, so this is a very important statement, right? Very important statement. Okay, because you will use it in the next part. So, and then angle. Okay, so you need to see that angle RTS is equals to angle, this angle, is equals to angle QTU, right? QTU is equals to alpha vertically opposite angles. Okay, so this is equals to alpha. Okay. Right? And then therefore in triangle TSR, okay, angle TSR will be 180 degrees minus theta minus alpha, which is equals to 180 minus theta plus alpha, right? Which is 180 minus 90 equals to 90, shown. Okay, so 5 marks, easily done. Yeah, class? So the same part 2, class, part 2. Explain why a circle passing through the points TRS or RST has its center at the midpoint of TR. So basically, so what we're saying is that we have a circle here. So essentially, because this is 90 degrees, right? So which means that TR is a diameter. Okay. So you say since angle TSR is equals to 90 degrees, circle with TR as the diameter will have center at midpoint of TR. Reason? By the converse of angle in a semicircle. Okay, done. So essentially what you're saying that because this is 90 degrees, right, it means that TR is a diameter. So if TR is a diameter, then the midpoint of TR is actually the center of the circle. Okay, so easily done. So remember, for proof, you need to state the reason. Okay, all the properties that you have learned in EMATH, as well as the two theorems, either the tangent chord theorem or the midpoint theorem. Okay. Okay, class. You have other questions as well from 17, 16, 15, 14, and 13. Okay, so you can try, and then I'll post up the solution for you, or you can send the solutions to me. Okay, I'll try and post the solution either tonight or tomorrow morning. And then at the end of this whole TYS questions, right? So I do also have other questions at the back, so you can actually try on your own, and I can also post up the solutions for you. Okay? Okay, so this is from 2016. So you're supposed to prove that angle APB, which is here, APB, right, plus angle ADB, ADB is here, is equals to 180 degrees. Okay, and then you're supposed to prove that PD is parallel to BC, given that APBD lie on the circle. So to prove parallel lines, you need to prove angles lah. You can either use interior angles or alternate angles. Okay? Okay, this is from 1915, right? Show that angle DAX is equals to angle BCA, right? So DAX is here. prove that this angle is equals to BCA. BCA. Huh. Not difficult. Again, you have parallel lines. So again, alternate angles. And then show that angle ADX is isosceles. You will see trends, class. So if you do enough TYS, you will see trends. So your 2022, 2021, 2020, you will see similar things being asked for circles. And then you see another trend like 19, 18, and 17, 3 years. Similar things are being asked. Okay? Okay, so this is from 2014. Okay, one of the slightly more difficult ones. Okay. Okay, and then this is 2013. Okay, so you don't notice that they usually will ask you to prove that it is isosceles. Then in later years, okay, they say that given the triangle is isosceles, prove that the angles are equal. You know, that kind of thing. So be alert. Yeah, so you try, and then you do it. 10-year series, there are answers, so you can check against the answers, or you can send your answers to me. Then I'll look through for you. Then I can give you a few other sums if you want to try. Okay. Okay, so this is one of the questions that I've taken from one of the assessment book. I thought this is quite interesting. So if you want to try, you may. If not, then you wait for the answers to be posted. Yeah, class? I will probably post a few more proof in Geom from other schools for your learning. Okay, class, so do not be intimidated by proof in Geom. It is doable. Okay, so you may want to put it towards the end, of the paper, then you do it, right? Or you think that you can actually do it, then you make sure that you do it within time. So do not spend half an hour on the proof in Geom question, because the rest of the sums for A-math especially, you can always solve and then prove that the answer is this, so you know that whether you're right, then you can go on. Okay, so proof in Geom, if you are not very sure, you put it at the end, but by then I think you should be quite okay, right? You should be quite familiar with it.